Hello everyone and welcome to Lee's R&D session number 6, where in this session we're going to be enhancing the terrain patch, which will consist of redefining the grid shape, a discussion about normals and tangents, and we're going to take a look at calculating said normals and tangents. So Lee, that's just the real quick blurb. If you'd like to kind of give us the more descriptive tour, that would be fantastic.
Yeah, no problem. What is going on is, as everybody's well aware of, this terrain is an R&D in progress. We are constantly testing and evolving as we go along, and we're trying to teach it as we're developing it as simply as we can possibly manage. And as such, with it being a work in progress, one of the things that we have come up with is, I can't even switch over to the scene. Could you do that for me, please?
Sure. There you go.
It's not responding for me. So there we go. I want to frame up. One of the things that we've noticed through all of our R&D being that level of detail is not going to be practical for us to be calculating on the fly. So with that in mind, I've come up with a couple more optimizations, mostly dealing with the shape of our grid, the way it's laid out. The way we've chosen to lay out our grid is based off of an isometric style grid. If I go to Photoshop, I've already got it laid out. But notice our edges are nice and flat all the way around.
Mm-hmm.
And we've got this kind of it's a nice shape, but it gives us an interesting problem in that our vertices are alternating in size. So on this row where we have, 2, 4, 6, 8, 9 vertices in this row, our very next row has 10, followed by 9 and 10, which has or does provide quite an interesting bit of math juggling that we have to do in code to make this happen. Well, this was initially designed so we could implement a level of detail, meaning we could line up grids next to this that were in powers of 2. So if whatever this count was, if our count was exactly half that or exactly double that, we would be able to line up our vertices next to each other. Since that isn't going to be possible with scripting inside of Unity, or it's possible but it's not performance reasonable, we don't need to have this added complexity. So one of the things we're going to be doing is modifying our grid so it has more of a shape like this. So basically where we're taking these extra vertices and squashing them in to form this straight line, we're going to get rid of them altogether. So it's going to simplify our overall grid shape. Because we don't have LOD, we're not going to have to worry about matching up the fit a patch next to it, because
Okay.
all of our patches are going to be the same.
So, quick question. So, what are you envisioning for the end of an actual grid? I mean, obviously, we would want to prevent a player from running all the way out to the edge of the world like that anyways.
Well, because of our train being spawned in every direction and
Mm-hmm.
generated, they're never going to hit the edge.
Right. Okay.
So they're never going to get to the end of the world going, oh my God, look, this is a zigzag pattern or this is a straight line, because they'll never get there. What I've got in mind based off of our R&D is where you define the shape of your continent, like we did with the UK map, where I would expect the artist to design their world or their zone to be almost like a continent surrounded by water. So as long as they design their map to edge off into water, if they ran to the edge of the world, it would drop off into an ocean,
Okay.
and they wouldn't get to the edge. If for some reason an artist didn't do that and it was no drop off to an ocean, the world would repeat.
Okay.
until you got to the point where we've demonstrated that the world starts breaking and the geometry starts falling apart.
Right.
But even then, where it's falling apart, they're not going to see the end of the world. You just can't get to it.
Right. Okay.
So the only time you'll ever see this edge is going to be inside of the editor itself.
Oh, I'm sorry. Go ahead.
I was going to say that is one of the first things that we're going to do is adjust this grid size. The other thing that we're going to do is, as you mentioned, we're going to be looking at a custom way of dealing with normals and tangents. So with us having these terrain patches, we get an interesting problem with the way Unity calculates normals. Is it calculates on a per mesh basis. So where we have a vertex in the center of a mesh, it does a very nice job of calculating what the normal would be based on the surrounding faces. The problem happens is when we get a vertex or vertices on the edge of the mesh, it doesn't have enough information to accurately calculate what the normal should be. Mm-hmm. Based off of the fact that we know there's a patch here to the right, but Unity doesn't know that it's there. So the information that it's using is incomplete. So it calculates the normal the best it can, but we end up with visible seams in our lighting because of that. So we're going to have to look at a different way of calculating our normals. The third thing that we're going to be looking at in this series is tangents. Unity does not allow you to calculate let me correct that. Unity does not give you a way to calculate tangents built in for meshes that you create. You can calculate tangents for meshes that you import. And this is kind of a fun part on the forums is everybody's like, well, we know you can calculate tangents because Unity does it. When you import it, you look at some of the options. It even gives you sliders to adjust how it calculates tangents mm-hmm. and where it puts the hard edges mm-hmm. based off of that. But they don't expose that functionality to the developers that are creating their own meshes. So apparently Unity believes if you're smart enough to create your own mesh, you should be able to be smart enough to create your own tangents.
Gotcha.
So we're going to be looking at creating our own tangents. Now there's several different ways to create tangents, but I'm going to show you a website where you can get information, and I'm going to point you in the direction of a book that also has a very good discussion on how to create tangents. Mm-hmm. We're not going to be using that though. It's fairly computational intensive. We're going to cheat because of the way our grid is designed and the way it's going to be positioned in the world. Mm-hmm. It's going to allow us to cheat and create our normals in a very fast way.
Normals or tangents?
Tangents. Actually, normals too.
Okay,
so
cool.
we're literally going to be cheating both.
Awesome.
Because I'm relying on the fact that this is our grid shape and we're pulling information from height maps, mm-hmm. we're going to be able to cheat how we create normals and tangents. And with our initial implementation, they're literally going to be slower than the other ways of creating normals and tangents. Mm-hmm. And I'll get into explaining why it's going to be slower initially. In a future upcoming set of videos, we're going to be fixing that as well. And I'll discuss that when we get to that point. Okay. But there's going to be a lot of stuff we're going to be discussing in this series of videos. Even though this will be one of the shorter ones, I'm guessing this will probably be around 10 to 15 videos. Okay. So we'll see how it turns out. But that was basically an overview of what we're going to be getting into.
Okay, fantastic. So then kicking things off in the very next video, I assume we're just going to go ahead and start getting that new grid shape into place?
Yep, we're going to go through the code and we're going to knock off these extra vertice calculations. And the first part is, if you remember back the way we create our train, it's done in several different layers. First, we calculate our vertices and our UVs. Then we go back and we calculate our triangles.
Mm-hmm.
And then after all that is done, then we actually update the mesh itself.
Mm-hmm.
The next video, we're going to be adjusting the way we calculate our vertices and UVs. And the video after that, we'll go back and we'll adjust the way we calculate our triangles for the mesh itself.
Okay.
So, and we won't have to change the way the update works because it applies in both cases. So adjusting the mesh will take place over the next 2 videos.
Okay, fantastic. All right, well, with that, that is going to wrap up this intro. Thanks, Lee, and we'll see everyone in the next video.